electricity, a powerful force in our world. A form of energy man has historically viewed with awe, superstition, and respect. The Greeks were aware of electrical charges as early as 600 BC. They found that rubbing amber, which they called electron, gave it the ability to attract small bits of material. Sailors once regarded St. Elmo's fire, which was in reality the corona from an intense electrical field, as an omen which foretold the severity of a storm. It was to be many hundreds of years before man learned to harness electricity. The invention of the three-element triode electron tube in 1906 provided the technology to amplify electrical signals, launching us into the electronic age. Electrical charges, when harnessed as electrical power, are a powerful ally, providing the energy to run our modern world. But electrical charges can be a destructive force and stop us cold. In the form of uncontrolled electrostatic discharge, ESD, this static electricity will interrupt or disable vital electronic equipment.
Stand by for observation Sierra 1.
Standing by, sir.
Bearing, mark.
Bearing, 300.2, sir.
Range, mark. 1 division, high power.
Range, 8,000 yards, sir.
Officer of deck, I have a fault on the weapons console.
Aye. XO, we have a failure of our weapons console.
Damage can be dramatically reduced by learning how static charges are generated and how they can damage electronic parts and assemblies such as these. There are several ways of generating a static charge, but the one of primary concern to us is frictional electrification or triboelectrification. Tribos is a Greek word for the action of rubbing. When two materials are rubbed or separated, one material gives up electrons and the other collects them. The material that gains electrons becomes negatively charged, and the one that gives up electrons becomes positively charged. Generally speaking, the more the materials are rubbed or separated, the more electrons are exchanged, and the higher the static charge is developed. An electrostatic discharge, or ESD, occurs when the accumulated charge is rapidly discharged to another object or ground. The magnitude of the charge developed depends on many factors, such as the materials used, speed of rubbing or separation, surface condition of the materials, and relative humidity. Static electricity can be annoying, and when discharged rapidly can be startling and sometimes painful. It can be useful, and at the same time, it can damage or destroy electronics. Static electricity has become a costly problem for electronic equipment. If effective ESD protection is not provided when handling, processing, or testing electronic parts and assemblies, they can be damaged or destroyed by the static electricity on your body or on the materials in the work area. How did static electricity come to have this devastating effect on electronics? Over the past 30 years, the parts used in the electronics industry have gone through some revolutionary developments. Electron tubes, the workhorse of the electronics industry since the invention of the triode in 1906, were replaced in the 1960s by transistors and other semiconductors. Then in the late 60s, new technology reduced hundreds of transistors and other parts into a silicon die or chip less than 1/10 of an inch on a side. The integrated circuit, or IC, had been born. And electronic systems of the 1970s could be built on a single printed circuit card. The trend towards smaller size and higher circuit density continues. We've moved from small and medium-scale integrated circuits to large and, yes, to even very large-scale integrated circuits. There are also very high-speed integrated circuits, or VHSIC. Each evolution brings smaller, more dense circuit geometries. Today, hundreds of thousands of transistors, diodes, resistors, capacitors, and their interconnecting paths are integrated onto a die or chip. Industry experts predict this will increase into the millions before the year 2000. These technological advancements brought significant benefits: reduced size and weight, lower operating voltage and power consumption, faster operating speeds, better performance, and higher reliability. And all this for a lower cost. But the technology to miniaturize structures and to integrate them together also brought with it the problem of parts and assemblies being susceptible to damage from small amounts of electrostatic charges. As the structures became smaller and their density increased, it took static charges with less energy and less voltage to damage them. Charges that are routinely stored on people and materials frequently found in the workplace. Charges that may be so small they can't be seen, heard, or felt by a human. So it's important for everyone to be aware of ESD and take certain precautions when handling electronic parts or assemblies. From manufacturing, testing, packaging, and handling to maintenance and repair, electronic equipment should be protected from electrostatic charges and ESD. The Navy recognized the importance of controlling static charges and prepared a standard to establish requirements and a handbook to provide guidance in implementing an ESD control program. These documents are the basis of the Navy's ESD control effort and assist us in maintaining a technological edge in equipment design, reliability, and most importantly, operational readiness. The seriousness of the problem becomes apparent when we consider that some electronic parts can be damaged by only a few hundred volts of static electricity. We can't feel an ESD unless the charge has reached 3,000 to 4,000 volts. So we can damage electronic parts or assemblies without even being aware of it. Being aware of the problem is the first step. Personnel should be trained about ESD.
Susceptible to a static charge, so you need to be aware of that and wear your wrist strap.
Implementing an ESD control program is the second step.
Well, I've just been taking some notes on what we might have to do, and the first thing is we're going to have to get an ESD mat. We're going to need the wrist straps.
Work areas where ESD-sensitive parts and equipment are handled or stored should be visited to determine the ESD control equipment needed for each area.
We just completed the inspection of the...
An ESD control program plan should be prepared and the policies and specific requirements documented. When ESD-sensitive items are received, they should be in ESD protective packaging, clearly marked to show that the contents are ESD-sensitive. Sensitive items should be kept in their protective packaging until they're required for inspection or use. Sensitive items should only be outside of protective packaging at an ESD protected workstation. Handling, assembly, rework, repair, and testing operations should be done at an ESD protective workstation. What is an ESD protective workstation? Generally, it's a temporary or permanent work area free of unnecessary static generating materials and products. The basic ESD protective equipment for a protective workstation consists of an ESD protective work surface, wrist straps, and their connections to ground. The ground connection may include a current limiting resistor for personnel safety. You can convert your existing workstation to an ESD protected workstation by removing materials that are prone to generating and holding a static charge. Install an ESD protective work surface and wrist straps. The wrist straps should be connected using a banana plug, alligator clip, or other easy release type of connector. Connect each ground wire to ground. Before beginning work at an ESD protected workstation, inspect the wrist strap and its connections to ground to ensure they're in good condition. Unless otherwise directed or instructed in your maintenance manuals or procedures, remove electrical power and wear a wrist strap when contacting electronics parts and assemblies. Keep defective printed circuit boards in protective bags or containers to prevent additional damage from ESD. ESD protective packaging or covering is required to protect sensitive parts and assemblies from damage. For shipment or storage, follow the requirements provided in NAVSUP Publication 484. To protect electronic items from ESD, the requirement is to use DoD-approved ESD protective materials. First, wrap the item using the static protective cushioning and insert this into the barrier bag. The static protective cushioning minimizes the generation of static electricity and dissipates static charges. The barrier material protects the item from static fields and other environmental effects. Seal the barrier bag and attach an ESD caution label. When soldering is required, it should be done at an ESD protective workstation in accordance with the standards and requirements specific to your equipment and activity.
The council's fixed the systems in configuration 1, sir.
The operational readiness of your equipment should not be compromised by failures caused by ESD. Equipment downtime and the number of man-hours spent doing unnecessary repair work will be minimized. The number of spare parts and assemblies used and their costs will be reduced. And personnel dependent on electronic equipment will have increased confidence in the reliability of the equipment, your ability to maintain it, and their ability to carry out missions. Any inconvenience associated with controlling static charges and ESD is minimal, especially compared to the impact of not controlling it. And for the Navy, the inability to carry out a mission carries far graver consequences. Every effort has been made to deliver the latest equipment to you free of damage from ESD. Now, it's up to you.